Okay, final structural material, final video for this course, masonry. And it's important to note here that when we talk about masonry, we're primarily talking about walls. Nowadays, masonry is not typically used for any type of floor framing systems, although back in around the 1950s, there was a terracotta floor system that had become very popular. So if you're doing a renovation of a space, you may run into that type of system, or some type of structural clay tile system, as it's also called. But nowadays, masonry is pretty much exclusively used for walls. And then the actual floor framing will be either some kind of precast concrete system, or a steel system, or a wood framing system. So within masonry, we have two basic types. We have concrete masonry units, which look like this. You may have heard them referred to as cinder blocks, but they're actually not cinder blocks. Cinder blocks are an older terminology for an older product that has now been superseded by concrete masonry units. And so basically, these are concrete precast units that come in standard widths and standard lengths, typically around 16 inches in length when you include the mortar that will be placed on either side between the blocks, and in standard widths, generally from about 6 to 16 inches wide. And you can see the standard dimensions for blocks here. And this specification comes from NCMA, or the National Concrete Masonry Association. And this manual that gives the standard sizes and section properties for masonry is Tech 14.1b. Now it's important to note with masonry block that when you look at it from a side view, you will notice that one end of these side walls of the block will be wider than another end. And you might expect that the wider end of the wall would go on the bottom, but that's actually not the case. The wider end of these side walls is going to be the top of the block. And that's so that they can place the mortar more easily when they stack these blocks. So the fatter end of the side walls is on the top, and the thinner end is on the bottom. Now with concrete masonry units, we can have either load-bearing or non-load-bearing. And what that means is basically load-bearing walls will take floor loads, and non-load-bearing walls will not take any floor loads. However, we do still need to design non-load-bearing walls to withstand their own self-weight. So just because it is non-load-bearing doesn't mean that there aren't any limitations from a structural perspective. And now the other type of masonry is brick. And brick is often used as veneer, and typically is not load-bearing. However, as I just mentioned, we still need to design it for its own self-weight, and we also need to design it for any lateral loads, such as wind or seismic. Now, as far as reinforcing is concerned, we can either have single-withe construction, where we just have one layer of block, and that block may have some vertical reinforcing in it, if it's used as a shear wall, for example. And it will also have horizontal reinforcement. And this horizontal reinforcement may not necessarily be at every single level of block. We can also have double-withe construction, where we have two layers of block. And in this example, we have a layer of CMU with a second exterior layer of brick veneer. And as mentioned previously in this course, the brick veneer will be tied to the CMU with these horizontal ties to stabilize it for lateral pressure. And in this drawing, the brick and the block are both bearing on a concrete foundation. However, if this were an upper level, we may have a relieving angle somewhere underneath this brick that ties back to the CMU. And that relieving angle would be to support the brick under its own self-weight. And the locations of these relieving angles will need to be coordinated with both the architect and the structural engineer, as they can slightly change up the look of the brick facade. Now, moving on, we can also have openings in masonry walls, and the block over these openings will need to be supported somehow for their own self-weight. And we do that through the use of lintels. And lintels can either be steel, as in this example, where we cut out a chunk of the bottom of the block and insert a double angle for the block to bear on. Or we can have masonry lintels, where we pour grout into one or more rows of masonry, depending on the span length, and insert steel rebar. And essentially this will act a lot like a concrete beam. And lastly, we can just use precast concrete itself. And typically the precast concrete lintel will be a lot shallower than the masonry lintel, as you can see in this example. So that's it for masonry for this course. If you are interested in learning more about masonry, again, I would highly recommend picking up this book here. Or if you have further questions, please feel free to email me at any time. As I said back in the beginning of the semester, now that you have taken this course with me, I consider us to be linked for life, so you can email me any questions that you have at any point in your career, and I'll do my best to answer those questions. The world of architecture tends to be a pretty small world, so there's even a chance that we may end up working together on a project. So with that, I'm going to pull up our structural material performance matrix one last time, and note that since we are only talking about masonry walls here, there are a few categories that don't really apply for masonry. However, the important things to note here are that masonry performs very well for fire resistance, hence why we use them typically for fire-rated wall assemblies. Masonry also has very high environmental resistance, hence why we use brick veneer for exterior facades. Masonry walls can also accommodate openings, and so they are generally fairly good for MEP integration. Also, holes in masonry walls can typically be made post-construction in a renovation scenario fairly easily due to the modular layout. Masons also tend to be very quick with putting up masonry walls. However, masonry block is very heavy, and generally they do require a fair amount of energy to produce. And so with that, I would just like to say thank you for paying attention throughout this course and for all of your effort. I know that structural engineering is typically the least favorite topic for architects, so I really appreciate you sticking through, and hopefully you've learned something valuable for your career. And so with that, good morning, good afternoon, and good night, and I'll see you next time.